Sarush, today we have to start with polar form of complex number and exponential form, which is also called as Euler's form of complex number. Polar form is basically a way of representing complex numbers using trigonometry, and Euler's form is basically representing complex number in the exponential form. So see, if we have a complex number z equal to x plus iy, if this is the standard form of a complex number, तो इसका जो polar form है, polar form होता है z is equal to r into cos theta plus I sin theta. जो r है ना आरुष, r is actually modulus of z. हमने कल सीखा था modulus.
Yes, sir.
And theta is argument of z. Argument का formula, if you remember, tan inverse y by x, and then you have to check the quadrant and decide whether it is pi minus theta, pi plus theta, or 2 pi minus theta, depending on the quadrant.
Yes.
So if the question is convert this normal standard form into polar form, then we'll have to do this. We'll have to first find r, that is modulus z, then argument, and then substitute.
Okay.
Coming to exponential form, so if we have z is equal to x plus iy as standard form, then the exponential form is z is equal to r into e raised to I theta. ठीक है, तो exponential form में again same thing, find r, find theta, substitute. So this is exponential form.
Okay.
ठीक है. Okay, now on the basis of this, let us understand one property which will be helpful. This property is actually called De Moivre's theorem. So Arush, if we have, let's say, cos theta plus I sin theta, the whole raised to n, where n can be any number. Now, do you realize, if you just check the polar form and the exponential form, that is the Euler's form, do you realize this cos theta plus I sin theta is as good as e raised to I theta? If you just compare both the forms.
अच्छा, yes.
तो
Yes.
एक्चुअली cos थीटा प्लस I sin थीटा क्या होता है, वो होता है e raised to I theta. तो अब जो प्रॉपर्टी है ना, उसका मैं प्रूफ दिखा रहा हूँ. So we can write this as e raised to I theta raised to n,
Yeah.
which is e raised to I into n theta. And do you realize, Arush, this can now be written as cos of n theta plus I sin of n theta. देखिए समझा.
Nice. Last one.
लास्ट वाला बेसिकली इसको ऐसे लिख सकते हैं ना, cos theta plus I sin theta. So e raised to I n theta. Now along with theta we have n also. So over here along with theta we will write n also. So cos n theta I sin n theta. तो actual formula ये है, ठीक है. This is the main formula. और उसका लॉजिक ये है, we can convert it to Euler's form and then वो powers multiply हो जाएंगे n and theta.
Okay.
Write this and then we'll take some sums.
Yeah.
So Arush, question number 4. Express the following complex number in polar form and exponential form. Exponential form is Euler's form. So let's do one thing. We will directly take question 4 का third subpart. So we have z is equal to 1 plus 7i upon 2 minus I the whole square. So first of all, Arush, we have to find the modulus of this number. How will you find the modulus of z?
Root 1 square plus 7 square upon.
So root of 1 square plus 7 square upon root of 2 square plus 1 square का square हो जाए.
हाँ sir.
So this is root of 50 upon 5 अब रूट 50 को थोड़ा
Yeah.
सॉल्व करना पड़ेगा। तो रूट 50 को हम लिख सकते हैं 25 इंटू टू।
5 into
25 बाहर आके 5 हो जाएगा एंड दैट
हो
5
जाएगा
विल
तो
गेट
रूट टू
कट। सो वी गेट mod z इज
टू
इक्वल टू रूट टू। तो यहाँ से हमें r मिल गया, r इज रूट टू। अब आते हैं आर्ग्यूमेंट पे। सो व्हाट विल वी डू विद आर्ग्यूमेंट?
the argument of the numerator minus argument of the
What I am not able to hear you clearly.
the argument of 1 plus 7i minus argument of 2 minus I square.
Correct. So argument of 1 plus 7i minus argument of 2 minus I the whole square. अब पहले तो 2 minus I the whole square को expand करना पड़ेगा, right? We'll have to use a minus b the whole square and
Hmm.
convert it into a normal form, normal standard form. So you do that and tell me what are you getting.
Yeah, just a second, sir.
Chalo, so you will get tan inverse minus 1 after converting this to tan inverse 7 minus tan inverse 2 minus I the whole square will become 4 minus 4i plus I square. So are you getting 3 minus 4i, Arush? You should get 3
Yes,
minus
sir.
4i, which is tan inverse 4 by 3 minus, फिर इसको tan inverse के प्रॉपर्टी से सॉल्व करके you will get tan inverse minus 1, right, which is pi minus pi by 4, which is 3 pi
5
by
minus
4.
5 3 5. Yes.
So now coming to the polar form will be z is equal to r is root 2 cos of theta is 3 pi by 4
3 pi
plus
by
I sin theta is 3 pi by
3
4.
pi.
And the Euler's form, that is the exponential form, that is r e raised to I 3 pi by 4. Done.
Yes.
ठीक है, ठीक है, then चलो let us now proceed to the next concept. Okay, we can take this, which is properties of modulus and argument and conjugate. Yeah, we can take this exercise.
Yeah.
Sure. So let us take the first sum. So we have z cube plus z bar, so conjugate, is equal to 0. So Arish, we have to find the number of solutions of this equation. So what do you remember about the properties of modulus and conjugate? And the some conjugate is there. So do you remember any property? There was one specific property related to modulus and conjugate. Do you remember that by any chance?
It's so modulus z is modulus of z bar.
Modulus of z is modulus of z bar.
Z
ठीक
bar.
है, that works. What else do you know?
Z into z bar is modulus of z bar square.
Z into z bar, correct. So we have z into z bar is equal to modulus z का square. वो भी राइट है। तो अब देखो हम लोग यहाँ पे करेंगे क्या आरुष? We have z cube plus z bar equal to 0. So do you realize I can say z cube is equal to minus z bar? Now if I
Yes.
take modulus on both sides, ठीक है, I'll take modulus on both sides.
Hmm.
तो इसको हम ऐसे लिख सकते हैं मॉड्यूलस z का क्यूब. डू यू नो दिस कि z क्यूब का
Yeah.
मॉड्यूलस इज सेम एज मॉड्यूलस z का क्यूब. वी कैन बेसिकली टेक द पावर
Yes.
आउटसाइड एंड मॉड्यूलस ऑफ माइनस z bar is basically modulus of z bar.
Z bar. Yeah.
And modulus z bar is modulus z, as you rightly said. So we can say
Hmm.
modulus z cube is equal to modulus z works.
Yeah.
Now do you agree with me, modulus z is actually going to be a number,
Hmm.
correct? तो हम क्या करेंगे, इसको एक साइड पे ले लेते हैं, विल जस्ट टेक देम ऑन द लेफ्ट हैंड साइड, दिस इज 0, वी कैन टेक इट कॉमन आरुष कि ये एक नंबर होगा,
हाँ।
एंड ब्रैकेट में आएगा मॉड्यूलस z का स्क्वायर माइनस 1, आर यू फॉलोइंग दिस?
यस। यस।
तो यहां से मॉड्यूलस z के पॉसिबल आंसर्स क्या होंगे?
So 0 plus 1 minus 1.
Modulus z is either 0 or modulus z is plus 1 or modulus z is minus 1. But do you agree
Minus.
modulus can't be minus 1? Modulus z is distance, right, at the end. So it can't be
Yes.
minus 1.
So it can't be.
Achha, modulus z equal to 0, what does that mean? We are talking about origin. Modulus will be 0 only when both are 0, 0. Root 0 square plus 0
Hmm.
square. So इसका तो एक ही solution है, which is 0, 0.
Yeah.
राइट, रिमेंबर वी हैव टू फाइंड नंबर ऑफ सॉल्यूशंस, तो फर्स्ट पार्ट का एक सॉल्यूशन आ रहा है, अब सेकंड पार्ट को हमें थोड़ा सॉल्व करना पड़ेगा, तो उसको कैसे सॉल्व करेंगे, देख हमारे पास ये है मॉड्यूलस z इज 1 व्हिच मींस मॉड्यूलस z का स्क्वायर इज 1,
Hmm.
एंड ये मैंने इसलिए किया, आई हैव स्क्वायर्ड बोथ साइड्स बिकॉज़ मॉड्यूलस z स्क्वायर का एक प्रॉपर्टी है अपने पास, दैट z into z bar is equal to 1.
Yeah.
From here can you tell me what is z bar?
1 by z.
1 by z, तो अब आरुष ये z बार को हम इसमें सब्स्टिट्यूट कर सकते हैं, so we can write z cube plus 1 by z is equal to 0. Are you following this?
Yes, sir.
Now when you solve this, what will we get?
Z raised to 4 plus 1
So z
is equal
raised to 4 plus 1 equal to 0. Now we had discussed this, that there is a basic rule in algebra that the number of answers is always
equal
equal
to
to
the
the
power.
highest power of the variable.
Yes.
So how many answers will this equation have?
4.
Correct, 4 solutions. Now do you realize आरुष, you have to now check कि हमें जो पहले solution मिला है 0 वो इसमें overlap हो रहा है कि नहीं, like out of these 4 solutions will 0 be a solution over here? So do you realize 0 can't be a solution, if z is 0
0 will not.
then it will not satisfy, so these are 4
Yeah.
different solutions, so total
Hmm.
there are 5 solutions for
5.
this equation.
Yes.
ठीक है, write this.
Yeah.
चलो next is Arush question 2. If a is positive and mod of z is a, find the real part of z minus a upon z plus a. See, mod z is a and z के बारे में हमें कुछ पता नहीं है, तो एक काम करते हैं, let us assume z as x plus i y.
I.
तो a is root of x square plus y
X square
square.
plus y square.
अब real part of z minus a upon z plus a, so z is x plus i y minus a अपॉन x प्लस आई वाई प्लस ए, इसको ना पूरा सॉल्व करना पड़ेगा, ये जो कॉम्प्लेक्स नंबर है इसको हमें थोड़ा सॉल्व करना पड़ेगा,
हाँ.
सो वी हैव x माइनस ए प्लस आई वाई एंड डिनोमिनेटर इज x प्लस ए माइनस आई वाई, सॉरी प्लस आई वाई.
Plus
सो
I.
आरुष
हाँ.
डिनोमिनेटर में i जो है, we'll have to remove this I from the denominator. How do we remove I from denominator? We had discussed this yesterday.
So we can square both the sides.
No, we'll not square both the sides because there's no other side. Like other side is
अच्छा.
just, I've just named it z1. ऐसे square नहीं कर सकते दोनों side का. But do you remember
So
how do we divide two
conjugate से
complex numbers?
multiply कर
Conjugate से
सकते.
multiply divide करेंगे. Correct. So we'll multiply divide by conjugate of denominator. The denominator में middle term का sign change करना है. So that is
Yeah.
x plus a
X plus
minus iy. And this is x plus a minus iy. अब
minus I.
न्यूमरेटर में पूरा एक्सपांड करना पड़ेगा,
हाँ.
so you do that and tell me what are you getting in the numerator and the denominator. So check this Arush, this is what you should get in the numerator.
Yeah.
When you expand completely, two terms will get cut, minus xyi plus xyi. and ये I square is minus 1. So now this is x square plus y square minus a square. बराबर? Check this. You should get this.
हाँ
Now in the numerator we have x square plus y square minus a square. But do you realize from the first equation x square plus y square is actually equal to a square?
यस सर
So we can replace x square plus y square with a square. तो ये कट हो जाएगा पूरा a square और minus a square.
हाँ
So do you realize that we are left with a purely imaginary number?
यस
So the real part is 0. Real part of z minus a z plus a is 0.
जीरो
Let me know once you are done.